All right, so in example 1, it says prove that the following equation is not an identity by using a counterexample. So let's try when x is 0. Yeah, for this one we're going to let x equal 0. So we've got the equation that sine of x minus cosine of x, all of it squared, would be equal to sine squared of x minus cosine squared of x. And we're trying to show that this is not true because it's not an identity. So if x is 0, then I see I've got sine of 0 in there, right? Well, sine of x then would become sine of 0. And what is sine of 0? Well, 0 has an ordered pair. Think about radians now. 0 radians has what is an ordered pair? 1, 0. Sine is what? X or y? Y. So, what is my y value? 0. I also see in this problem I have cosine of x, which means I would be doing cosine of 0. Cosine is what? X or y? X. And what is my x value? 1. So let's go plug those numbers into that equation there, okay? So we've got, I'm just going to rewrite it first. So we've got sine of x minus cosine of x, all of it squared, is equal to sine squared of x minus cosine squared of x. All right, so we know that this is going to be if x is 0, then it's sine of 0 minus cosine of 0 squared equals sine squared of 0 minus cosine squared of 0.
But I thought we just...
Well, we're going to plug in now. I was just replacing the x value there, okay? So now let's plug in what we know. What is sine of 0?
0.
Minus, what is cosine of 0?
1.
Close it, square it. And we said that's equal to, what is sine of 0?
0.
Oops, I don't need to print. Yeah, I do. 0 squared, because it was sine squared, right? Minus, what was cosine of 0?
1.
Squared. So on the left side there, we have 0 minus 1, which is negative 1 squared, equals, on this other side, what is 0 squared?
0.
And then we got our minus, what is 1 squared?
1.
All right. And on the left, what is negative 1 squared?
1.
Equals, and on the right, what is 0 minus 1? Are those equal? No, those are not equal. Therefore, this is not an identity.
So can we just pick any number to be x?
Yes.
Okay. And now x will make it...
Now, that's not saying no x would work, but not all x's will work. Okay? So, that doesn't mean, it's just showing you that, like if I took sine squared plus cosine squared equals 1, and I plug this in, it will work. If I take 1 plus tangent squared of x equals secant squared of x and plug in the 0, it will work. Okay? If I take any of those identities that we have so far, it will work for 0 and for all other numbers, okay? But this is just one example. Did you know which number to pick? Not really. I had to guide you there, okay? So, but if it did tell you to find a counterexample or prove that it doesn't, you may have to try a couple values before you find one that actually doesn't. Because it could work for some, it's just not going to work for all. An identity will work for all of them. All right, so what I was writing there, it says for x equals 0, the two sides are not equal.
I thought you said we were only working on one side or something.
Okay, hold on. Therefore, it is not an identity. The only reason we went ahead and worked this one on both sides like this was because we were trying to prove that it's not. Now, typically, when we're proving that it is an identity, we're proving that this is true, whatever they give us. We usually do work one side, but remember I said there are times that we'll get stuck, and so we'll have to go and work the other side, okay? So usually you want to just work one side when you're proving that it is an identity, but there are still times there we'll have to do both sides.